Assalamu alaikum wa rahmatullah. Dear students, today, inshallah, we're going to talk about chapter 4 or network access layer. As we discussed last time, the network access layer as part of the TCP/IP protocol model is divided into two layers, the physical layer and the data link layer. So in this chapter, inshallah, we're going to talk about both layers. So the chapter is divided into four sections, two sections per layer. So the first section is the physical layer protocols and the network media, which summarize all the issues related to the physical layer. And then we're going to talk about the data link layer protocols and medium access control, which are related to the data link layer. So to start, as we talked last time, that the network resources are shared between multiple users, and the best way to understand how the network access actually works is to imagine yourself organizing a very large conference which is composed of many rooms. Each room hosts a session between multiple people, and you need to control the access to the different rooms and the different corridors between these rooms to facilitate a successful conference. So you need to provide some physical resources within each room to organize the discussion within this session. You also need to make sure that the corridors or the media that people will walk through these rooms will not be congested. So this is exactly the function of the network access layer. So to start, we know that the physical layer or the network control is composed of many physical components. One of them is the router, and the router facilitates the physical connection between the different hosts. So you have some connectors which connect the different rooms using Ethernet, and you have the internet connection which gives you the internet service. So you can use the NIC card or the network interface card inside your laptop and connect that to one of the connectors in the router to have a network connection. And then from this connector, you connect your router to an internet service provider like Ooredoo to get the internet access. So some of these physical connections facilitate a network inside your house. So you can have a wireless router which connects devices through wireless technologies, and you can have some PCs or some laptops which are connected through wired cables. Of course, some of the issues related to wireless are the ranges of communication, which restricts the range of communication between the lower floor and the upper floor, for example, in which case you need a specific physical device that extends the range of wireless communication to facilitate the communication between the different locations or the different floors. So these are some of the technologies and tools that are used to connect devices together. So physical layer talks about the transfer of bits from one device to another. So as we talked last time, bits is the lowest level of protocol data unit, which is used by the physical layer to represent all our information, despite the type of information, whether it's video or audio or anything, into a set of bits which can be transferred over a specific type of media. And the physical layer actually uses these bits to convert them into signals and facilitate the transmission of these signals over the different type of media. So depending on the type of media, and as we will talk later, we have different types of cables. So there are three major basic fundamental types of signals that can travel through the different type of media. We have electrical signals, and this electrical signal can travel through a copper cable, and we'll talk about the different types of cable within that category, the copper cable. And we have light pulses, so the signal can travel through the medium in a form of a light pulse. and that's used for fiber optic cables. And of course, for wireless, the signal can travel through the air using the microwave signals. And for wireless, of course, we will talk about what AM and FM and PM means, basically changing the amplitude of the signal or the frequency of the signal or the phase of the signal, as we will talk later. So regarding standardization in the physical layer, there are multiple organizations which they actually develop the standards in the physical layer. So we have ISO and we have ITU and we have IEEE. And the different standard organizations, they develop different standards in the physical layer, which are summarized in this table here. So we see that the most common and the most important one, which is IEEE, which standardizes the access technologies, including 802.3, 802.11 for wireless, and 802.15 for Bluetooth. And these are the access technologies. ISO as well, they standardize the physical connectors, including RJ45 and RJ11, which are used by the copper cables, as we will talk later. And of course, we have the ADSL. We're all familiar with ADSL, the asynchronous digital subscriber line, and which is standardized by ITU. Okay, so we see that different physical components exist in the physical layer. So the physical layer actually includes three main functions. First, it actually defines these physical components and how they are connected together using the different types of cables, and uses different technologies for what we call encoding and signaling. So encoding talks about the fact that we convert the set of bits that are transferred by the higher layers, we convert them into what we call codes. And a code is a set of signal representation or a set of levels of voltage which are agreed upon, and they are suitable for transmission over the different types of medium. So for example, we have what we call Manchester encoding, which encodes a zero, for example, as a higher voltage and a lower level voltage, and then the one will be the reverse of this, so it will be a lower voltage and then a higher voltage. And through a composition of these small voltage levels, we can represent the set of bits into codes, and then we transmit these codes using signals over the medium. We also have another encoding technique which is called non-return to zero, in which case the zero is simply represented through a 0 volt, and the 1 is represented using like 3 volt or 5 volts. And then the signal will be like a staircase signal, which can then be transmitted over the media using whether electrical signal or light signal and so on. We also have the signaling. So physical layer defines also the signaling technique, and the signaling talks about the fact that how we represent the ones and zeros into whether electromagnetic signal or electrical signal or light signal that can be transmitted over the suitable medium. So how the 1 and 0 are represented in a form of a signal which is suitable for a particular type of medium. And for signaling, we have both asynchronous type of transmission or synchronous type of transmission. And the simplest way to understand the difference between the two is to know that the synchronous transmission uses a clock, which defines an organized and equally sized cycles that can be used to transmit the signal. Whereas for asynchronous, the asynchronous transmission does not use a clock, which means that the duration of the signal and the spacing between the different signals can vary and not following any synchronized clock. So signaling can use as well one of two types of technologies, whether the signal can actually can use so this is the signal that we're trying to transmit, and we have two types of technologies which are used to represent this signal on the line. whether using a variable frequency, so we call it frequency modulation or FM signal. So what we do is that we compose the FM signal through a carrier signal with high frequency and the input signal or the modulating signal, and the composition of this will be, so if it's high, this means like high frequency. If the voltage is low, we use lower frequency, as we can see here. So we see that there's high frequency and lower frequency, high frequency and lower frequency to represent the amplitude of the signal. In the AM amplitude, on the other side, we change the amplitude of the carrier signal depending on the modulating signal. As we can see here, the amplitude of the signal is first is going up and then going down and then going up and then going down. So we don't change the frequency of the signal, but we change the amplitude of the signal. So these are two of the common types used for signaling in the physical layer. The different physical media support the transfer of bits, and usually the amount of bits that can be transferred over a particular media is measured using what we call bandwidth. So bandwidth measures the amount of bits that can transfer over a specific physical media, and it's measured using units like bits per second or kilobits per second, which is like 1000 bits per second, megabits per second, and so on. The bandwidth measures the amount of bits transferring over the physical medium, and in that regard, it's a theoretical limit of that particular physical medium. And as we will see later, is that this theoretical limit can almost never be achieved in reality. For that, we define another important concept, which is throughput. The throughput is the measure of the actual achievable transfer of bits across the medium from one place to another, which means that using some physical medium as well as some network devices, what is the actual amount of bits that we can get on the other side. And in many cases, this throughput is lower than the bandwidth due to many factors. Some of these factors include actually the latency created by these network devices, and as we will see later, some of the bits can arrive in error, in which case we have to do retransmissions. Some of the frames can actually collide together, in which case we have to retransmit these frames again, in which case the actual throughput that we achieve is significantly lower compared to the theoretical